seas and oceans are an inexhaustible source of natural assets. It is also an area which provides great possibilities for obtaining huge amounts of green energy. Therefore, oil and gas extraction from the seabed, as well as energy farms, have become a dynamically developing branch of the economy. As a result, the huge constructions used in the maritime industry pose big challenges to designers and manufacturers. We are visiting HFG Polska Company in Opole, where we will show how such steel giants are made. These are, among others, large structures for erecting wind farms or frames for lifting structural elements of drilling platforms. Individual components come from specialized cooperating companies, prefabricating sheets with a thickness of 20 to 130 millimeters, and composition ensuring resistance to seawater. Sheet metal elements up to 20 millimeters thick are cut using plasma, and oxy-acetylene torches are used for plates above this value. The cut must be extremely precise. Finished parts are sent to the next stages of the process. Cylinders and cones up to 4 to 5 meters in diameter are formed at another cooperating company. Here we see how the shape of the cone is being bent. Auxiliary lines have been drawn on the section made of 12 millimeter thick sheet metal, allowing the operator to control the course of operation. Two elements are obtained to be welded into the cone. On this machine, we can see how the cylinder is produced. First, the ends of the sheet have been rolled to obtain the initial radius. Next, after cutting off the allowances, the actual rolling takes place, and after welding the ends, the cylinder is calibrated. Parts prepared in this way are finally delivered to the HFG Polska yard in Opole. Here, big things become huge. To begin with, let's have a look at how diagonal tubes are welded for fenders used on ships. These are used to transport loads. Here, we can see the construction of another element of the template, and then welding the transport stabilizers. This work is done by an automatic welding card that joins the two pieces together while moving. This greatly speeds up the process. Welded elements are flame straightened. This way, stresses inside the material are eliminated and steel deformations are leveled. Now let's see how the element of a special template is created, which will be used to drive the piles into the seabed. The sea windmill will be placed on these piles. Such a template has to withstand extreme conditions for at least 10 years. This is how the column production process looks like. First, two 8-meter pieces are welded together. The elements are connected using sheets and mounting pins. Subsequently, full pen welds are made, which will ultimately be subject to ultrasound and magnetic particle tests. These tests are aimed at ensuring high-quality construction joints that will be subjected to high dynamic forces at the bottom of the seas and oceans. Now let's have a look at the column after installing the next elements that make up the structure. Currently, it weighs 22 tons. Eventually, it will reach 34. A total of 6 of them will be built and placed in cylinders with a diameter of 270 centimeters. Meanwhile, another element is being prepared for welding. Its surface is dried to remove moisture for the welding process, which in this case is performed by the submerged arc method. Large structures undergo further processing. Surfaces and holes are drilled using a plate boring machine. They are then shot blasted and coated with a seawater resistant paint. Finished products are transported to the investment site. If the water level allows, the largest ones, about 45 meters long and weighing 250 tons, make their journey along the Odra River. Then they head for the salty waves of the Baltic or the North Sea awaiting them.